In this video, I shall discuss some previous questions asked for competitive examinations like NET, GATE, etc. NET December 2011, symmetry group of ethane in its staggered conformation. You may recall in the demonstration of sigma D's, we had explained the various symmetry elements of staggered ethane. This is the Newman projection formula. It has got a C3 axis and there are three C2 axes perpendicular to it. So it is a dihedral group and it has no sigma H, but it has got sigma V's. Sigma V's are bisecting a pair of C2 axes, So they are better called sigma D's. So the point group is D3D. The option box is correct. NET June 2012, the molecule that has an S6 symmetry element. Let us analyze each of the options. Dibrane, if you recall the structure of dibrane, it has got a 3 C2 axes, a plane of symmetry, 2 planes. All these will lead to D2H. In the case of CH4, it's a tetrahedral molecule, TD group. pH5, trigonal bipyramidal, it will be D3H. And in SF6, it is related to the octahedron. So it belongs to OH group. And what are the operations in OH group? There is identity, 4C3, 3C4, then there is C2, 3C2 corresponding to C4 squared, there is I, there is S4, there will be 3 S4 and 6, 4 S6, and of course there will be 3 sigma H and finally 6 sigma D. In the previous video, under special group, we had explained the symmetry operations present in OH group. So it has got an S6. The answer is option dog. Next, NET June 2013. NET June 2013. A molecule contains the following symmetry operations. A molecule contains the following symmetry operations. Identity, 2C6, 2C3, C2, 3 sigma D and 3 sigma V. A molecule contains these symmetry operations. The number of classes and order of the group is number of classes and order. Classes and order. And order of the group. The options are A 3, 12, B 5, 12, C 6, 12, D 6, 6. Analyze the list of operations. Identity, C2C6 means it is C6 and C6-5. And C6-2 will be actually C3. And C3 generates two operations, C3 and C3 squared. C6-3 will be this C2. And it has got 6 sigma V's which are present in two classes. If a C and V group will have n sigma V's, and if n is an even number, they will belong to different classes. So what I am arriving at is, it belongs to the particular group C6V. The operations are written class-wise, 1, 2, 3, 4, 5, 6 classes, and total number will be 3 plus 1 plus 2, 3 plus 2, 5, 6, 9, 12. Answer is 12. 6, 12. Identify the symmetry group in the following molecule. Again, net June 2013. Identify the point group of this molecule, which is a square cyclobutane structure having one X projected to the top, another X here, then here is an X, and this is X. It is also mentioned that the carbon-carbon bond lengths are all the same. You may proceed by the general scheme, but with a little experience, you can easily find out the point group of this. First of all, imagine such a line. 180-degree rotation, these two get interchanged, these two get interchanged, so this is a C2 axis. Then what about an axis like this? An axis like this. If you rotate the molecule, the X down will go to this side to the top, and X to the top will come here down. Here also these are interchanged, and it has got one more C2 axis. So one C2 axis is the principal axis, other two are perpendicular to the principal axis, and it is also clear that it has planes. In this way, it is a plane of symmetry. This is another plane of symmetry. When these planes are bisecting the C2 axis, so these planes are dihedral planes, so there is identity C2, 2C2 perpendicular to C2, then there is the plane 2 sigma D's, and because the principal axis C2 will also be coaxial with S4, it will have an S4. So the point group will be D2D. The options given are A, C2V, B, S4, C, D2D, and D, D4D. Evidently D2D. This was asked in June 2013 for the NET exam. Fifth one, I am only selecting those questions which can be explained from the theory of the topics so far covered in my previous video classes. Only those questions are selected. NET 2014, June. The result of the product C2x and C2y. What is C2x, C2y? We have worked it out earlier. The product of two proper rotations will be another proper rotation. It can be easily shown to be C2z, and the options given are A, identity, B, sigma xy, C, C2z, and D, I. How do we show that it is equal to C2z? Consider the general point of coordinate xyz. First you carry out the C2 y operation. Y will not change, the others will change to their negative values. And then carry out the next operation C2x. Here the x will not change, minus x remains as minus x, other two will change, minus 5 and z. Now what is the single operation that will convert a general point xyz to minus x minus yz? It is rotation about the z axis by 180 degree. Z will not change, others will change to negative value. In next question, which is NET 2014. Question number 6. The low temperature F19 NMR spectrum of sulfur tetrafluoride shows double triplet. It is consistent with the point group symmetry. I'll repeat the question. The low temperature F19 NMR gives double triplets. This data are consistent with the point group symmetry. Option A C3V, B C4V, C TD, and D C2V. SF4. We already know that sulfur tetrafluoride has an sp3 dehybridization, trigonal bipyramidal hybridization, and the lone pair occupies one of the equatorial positions, and the other positions are occupied by fluorine atoms. The importance of F19 NMR result giving double triplets. There are two signals, each is a triplet. It is due to the spin-spin interaction of one set of fluorine atoms with another set of fluorine atoms. That means the four fluorines are of two types. The equatorial fluorines is one kind, the axial fluorines are of the other kind. And consistent with the NMR result, the only possible structure of SF4 from the options is the seesaw structure consistent with C2V symmetry. So the answer is C2V. You will get one triplet like this, then another triplet due to spin-spin interaction. The axial SF bonds are longer, equatorial SF bonds are shorter, and the bond angle is much less than 120 degree due to repulsion with the lone pair. Then next question, question 7. It is asked in NET December 2014. December. The product of sigma xy and S4z. What is the product of these two operations? The options are A C4z, B C4z into I, C C4y, and D C2z. Very easily one can work it out because sigma xy is there. What is the improper axis of order 4? It is C4 followed by sigma C4z followed by sigma xy, lying perpendicular to C4. If C4 is corresponds with the z axis, the horizontal plane perpendicular to the z axis will be the xy plane. Now, if you combine these two, sigma xy and sigma xy, sigma squared is identity C4z, or it is essentially C4z. The answer is option A, C4z. Then NET 2015, NET June 2015, question number 8. I am not writing the whole question, but only the important points in the question. What is the product C2x sigma xy? What is the product of these two operations? The options are sigma xz, sigma yz, C2y, and C2z. You can easily work out the answer by doing these operations on the coordinates of a general point x, y, z. First of all, you do sigma xy. X and y will not change, but z changes to minus z. Then you carry out C2x. C2x Here the x will not change, the others will change. Y changes to minus y, minus z changes to z. Now what is the single operation that will convert xyz to x minus yz? It is reflection about the xz plane. xz plane, x and z will not change, y changes to minus y. So the answer is sigma xz, option A. Then net 2015, December 2015, question number 9, rub it off. The molecule diborane belongs to the point group. Diborane, we know it is a H, B, H, other B, H, H, these are in one plane. There is a hydrogen projected to the top, there is another hydrogen below that, the so-called banana bond, and this is a C2 axis. This will be another C2 axis, and this will be another C2 axis. So it is a dihedral molecule with a sigma H. This is, if this is the principal axis, this is sigma H. So it is identity C2, 2C2 perpendicular to the main C2. Then it has got sigma H, and of course it will be 2 sigma V's. And this point group is D2H. The options given are A, C2V, B, C2H, C, D2D, and D, D2H, and the answer is D2H. Net June 2016. June 2016, question number 10. This is the question. The symmetry point group of the most stable geometry of the following molecule. This is the molecule ClH, C double bond, C double bond, CH, Cl. 1,3-dichloro-propadiene. We had written its Newman projection, the front carbon with one hydrogen here and chlorine here. The third carbon with its chlorine here and hydrogen here, and the middle carbon not connected to any group other than the two carbons. And this picture clearly shows that there is a twofold axis of symmetry bisecting this dihedral angle. The options given here are C2, B, C1, C, C2V, D, C2H. The only symmetry present in 1,3-dichloroalene or propadiene is a C2 axis, therefore it belongs to the C2 group. This was mentioned in our previous classes as an example for C2 group. Then net June 2016, again 11th question. What is the point group symmetry obtained by adding symmetry operation sigma H to the point group C4? Suppose you add point group C4, add sigma H to it, new point group. This is the question. Let us write the operations of the C4 group. It has identity C4, C4 squared, which is the same as C2, then C4 cube, C4 which is identity, then you are adding sigma H to it. When sigma H is added, you have to consider the product of sigma H with these operations. What is sigma H into C4? That will be S4. S4 generates S4 cube. Then sigma H multiplied by this C2. C2 is Z and sigma H is sigma XY. So we have C2 Z sigma H XY, which is the same as S2, which is the same as I. So this has got I also. This group having C4 coaxial with that S4 and the C2 and sigma H, it is evidently C4H group. C4H group. The options given are A S4, B C4H, C D2H, and D D4. So the answer is box C4H. Then net December 2016. December 2016. Question number 11. Question number 11. The molecule that possesses S4 symmetry is, which is a molecule that possesses S4 symmetry among the options? S4, ethine, B allene, C benzene, and D 1,3-butadiene. First of all, you identify the point groups of these. Many of these examples were done during our theory classes. Ethine is a linear molecule with a sigma H, so it is D infinity H. Allene is propadiene, it is D2D molecule. Benzene is D6H, and the last one, butadiene, it can be cis or trans. Trans-butadiene is C2H, whereas cis is C2V. Which among these has got S4? It is evidently is D2D. In D2D, the operations are identity, C2, 2C2 perpendicular to C2. Then there is no sigma H, but there are two sigma Ds. And coaxial with the principal axis, there is also S4. S4 generates another one, S4Q. The total number of operations in the DND group. DND group should be 4n. So here it should be 4 into 2. There has to be 8 operations. Let us check whether 8 operations are present in this list. 1, 2, 3, 4, 5, 6, 7, 8. 8 operations are there. Then December 2016. Again December 2016, question number 12. It is question number 13 now. The earlier was 12. The point group symmetry that is associated with only polar molecules. Question 13. Point group symmetry associated with polar molecules. In my previous video, I said that polar molecules having dipole moment can have 3 types of point groups, either CS or CN or CNV. Only molecules belonging to these 3 can have permanent dipole moments. Let us see the options given for the question. A, C2V D infinity H. B, C3V C2H. C, D2H TD. And 4, C2V C infinity V. C2V and C infinity V belongs to the general notation CNV. So permanent dipole moment is possessed only by the molecules of the last option. Next question, 14. That was asked in NET June 2017. Question number 14. The compound N2F2 The compound N2F2 has two isomers. Choose the correct option. N2F2 has two isomers. Choose the correct option from the following. A. Both isomers possess sigma V plane. B. Both isomers possess sigma H plane. C. One isomer has sigma H and other isomer sigma V. Then none of them. D. None of them have sigma H plane. By the by, N2F2 has nitrogen connected by a double bond. It is the trans isomer. This is the cis isomer. From the look of these structured, it is very clearly symmetry is C2H and this is C2V. So which of these? C2H has a sigma H, C2V has a sigma V. So the option will be one has sigma H and other has sigma V. This is correct. Option C is correct. The correct relation involving symmetry operations. This is asked in NET 2017. 2017 again. Question number 15. The correct symmetry operations. Option A. S4 squared equal to S2. B. Sigma X Z sigma Y Z is equal to C2X. C. S43 is equal to C43. D. S63 equal to S2. Which relation is correct among these? You can analyze each. S4 squared cannot be S2 because S4 squared is C4 sigma H squared, which is C4 squared sigma H squared, or C2 into identity. It is simply C2, not S2. Now XZ and YZ, if the product of two planes of symmetry will be an axis with the common number notation Z, the product will be proved to be C2Z, not C2X. And S43 is C43 into sigma H, no sigma H, but this will be C63 and sigma H3. C63 is C2 and sigma H3 is sigma H. C2 into sigma H is S2, which is also the same as I. So this is the correct option. Dog is the correct option. Then a few questions from GATE. Question 16. The symmetry point group of BF3 molecule, boron trifluoride, BF3. What is the point group? Options are C3V, D3H, C2V, D2H. You know the answer? BF3 is a planar triangular molecule having sigma H and C3. B, F, F, F. This is the C3 axis. This is sigma H and it has got three such C2s. So it is identity C3, 3C2 perpendicular to C3, sigma H. It will have sigma V. The point group is D3H. Such a point group is D3H. Options B is correct. It was asked in GATE 2001. Point group of free nitrate ion. Point group symmetry of a free nitrate ion. Free nitrate ion actually is a triangular planar molecule having, this is the resonance hybrid of nitrate, and the look again compares with boron trifluoride. The answer will be D3H. among the options D3H, C3V, C3H and D3. The correct answer is option A, D3H. Now there is an interesting question from GATE 2003. GATE 2003. There are two lists given, list 1, list 2. This is CrP, CrH2O 6 times, 3 plus Q, Fe2CO 9 times, R, eclipsed ferrocene. List 2, 1 C3V, 2 D3H, 3 OH, 4 D3D, 5 D5H and 6 D4D. The options are, you have to match these two. Option A, P3 Q2 R5. Option B, P2 Q4 R1. Option C, P6 Q2 R5. And option D, P3 Q6 R4. Among the molecules of list 1, two are familiar to us. Water is considered as a single unit. This has square bipyramidal or octahedral symmetry. So this should belong to the octahedral group, which is OH. And we have no immediate idea of iron Nia carbonyl structure. Eclipsed ferrocene was discussed during our previous classes. Due to the eclipsed nature, it has a sigma H and it has a pentagonal symmetry. C5 is there, sigma H is there, so it has to be D5H. D5H, this corresponds to 5. And look at the options, 3 and 5 are sure. P3 and R5, it is only present in option A. Nowhere we have P3 and R5. So by eliminating others, the answer should be A, Q2. That should be the symmetry. D3H symmetry should be for iron carbonyl. The structure of iron carbonyl is actually like this: Fe, carbon monoxide, there is another one, CO, then here also CO, here there is a CO, and here there is a CO, here also there is a CO. So it has got a C3 axis, there will be a sigma H, and ultimately the symmetry can be easily shown to be that of D3H, Q2. Then GATE 2006. What is the question? A molecule has a two-fold axis and a mirror plane perpendicular to it. The point group must have, it has a C2 axis and a plane perpendicular to it. Already in the question, presence of these two elements of symmetry are given. Options are, it has a C2 axis, it is already in the question. Option B, it has a center of inversion. Option C, it has a sigma H plane, already in the question. Option D, sigma V plane. You know, when these two are present, C2 and sigma H, its product being I, it should have a center of inversion. That's the answer. Then symmetry elements that are present in boron trifluoride. Question number 20, GATE 2006. 2006. Boron trifluoride, we all know that it is a planar molecule, D3H symmetry. So all the symmetries of D3H are in the options. Let us see which is the correct option. A C3 sigma V sigma H 3C2, B C3 3C2 S2 sigma V, C C3 3C2 sigma H S2, and D C3 sigma H sigma V and I. S2 means I. Boron trifluoride, although it is highly symmetric molecule, it has no center of symmetry. So all options with center of symmetry in it are wrong. Here also is too wrong. The correct option is A, C3 3C2 sigma V sigma H. Okay, I am stopping the class here. There are a few more questions which we shall do in our next video. Thank you.